Well, hello everyone and happy 2024. Our good friend Marc Taylor is here to help us launch the new year. Marc is the senior manager of the planetarium and science programs at the Hudson River Museum in Yonkers. And there may be a few of the club members out there who are not aware that prior to our coming to PACE, we used to hold our meetings right in their planetarium section. And we do have many fond memories of those days. But now on to our guest. Marc is a 1993 graduate of Carleton College in Northfield, Minnesota. It was while he was on a job internship at NASA's Goddard Space Flight Center that he discovered that he would like to pursue a career in science education. Marc's talk will be focusing on something new, something which has recently been injected into how astronomy and science has been presented to young people as well as to the general public. So here's Marc to further elaborate on that. Please give him a warm welcome.
Oh, this camera, yes. We'll do that in a second, but we have to first do a little technology.
Just in case, I just want to plug the computer in.
Uh,
Well, I would have to start the Zoom and
Yeah, it's okay. If you can pop them on here. My laptop. Well, sorry for the technology delay. Gordon, who is the main computer guy, isn't here, so we have to do this. Make him feel guilty, Lisa.
so this is folder.
No. Okay.
Anybody notice my sweater had a hole in it?
No.
It's probably your favorite though, right?
No, all my sweaters have holes.
Well, that was it.
It's just this one.
Oh, right, oh, it's a whole. Okay, so I'm going to share this screen.
We just asked while we were waiting, has anybody here been to the Hudson River Museum before?
With you.
When was the last time you went there? Anybody? Has anybody been there in the past year? Okay. Anybody been there in the past month?
Nope.
Okay. All right. So I've been at the museum for a while, and if I have seen you before and I don't remember, then I'm sorry because I see lots and lots of people. I have, when I used to live in Westchester, I would go to the Barnes and Noble on Central Avenue, and I remember one time there was this little kid who was hiding behind his mother, and I looked at him, and she said, "Oh, he remembers you from the planetarium." I was like,
I was just doing this.
I still have a resume from the very first intern that I had, who now has 2 kids and is a science teacher. Thanks for bringing the cookies. Sorry.
Oh,
We're almost ready.
she's our cookie maker. Eva.
Almost ready.
I don't have all the images I was planning to use, so I may have to describe things here and there.
All right.
But with the power of your imagination, I think things will.
Almost
Okay,
there.
so should I
Almost
disconnect?
there. Yeah, disconnect.
this? Heard somebody say, "You can." Okay, so are we ready?
I just got to do one more thing for the folks here. Now we should be golden.
Okay.
Can somebody out in the blogosphere tell us that they can hear us and that they're seeing a blue screen with a little dot and a line on it? Good,
Yeah.
okay.
We can hear you and see you fine. Just the camera.
Oh, kind of makes the
Camera.
camera good.
Right.
Yes, we don't want to. That was just. Okay, making sure, yes.
Perfect.
Okay. All right. So what I wanted to do, rather than talk about telescopes or about planetariums per se, or even about really what it's like to teach on a day-to-day basis, what I wanted to talk about was to use an image or two just to give you an idea of how I came into education, why I think that today it has to be done kind of differently, and some of the things that are driving that. So what I tried to show here, this is a representation of something inspirational that happened to me when I was in college. I was walking across the campus and I looked up and I saw that. Now, as a teacher, I have to turn to everybody and say, what do you see? What do you think you see? What do you think that is?
Here,
Meteor, okay. Other ideas? I'll point out that the thing at the end of that streak is black. So it's probably not a meteor, right? It must not be something that's giving off light. So it's getting backlit. And then there's something bright up in the sky next to it. Okay, well, here's what it was. I was walking across campus in Minnesota and I looked up and I saw an airplane. And this airplane had a contrail behind it and it flew right by Jupiter. Now, the thing is, I had just started taking an astronomy class. And when I saw this, I recognized it and I said, oh, I remember that from class. That's Jupiter, cool. But then something really weird happened. Some of you might remember the movie Vertigo. In Vertigo, there's this guy who is afraid of heights, basically. And the way that they did that effect is they did something that you see a lot in movies today. I can't remember the exact combination. You like go from narrow angle to wide angle while you move the camera in, but you've seen that effect before of someone looking at the camera with a weird look on their face and then the background sort of stretches out in some strange way, right? That happened to me because when I looked at this, I knew how big an airplane is. I mean, this is out in Minnesota. I flew out there in an airplane. And to me, it was just a dot. There was this little tiny dot in the sky. And then beyond it, there was this bright spot. And I knew that that bright spot was Jupiter. And to give you an idea how big Jupiter is, here's my thermos. And anybody else have a thermos like this? You have one, right? Okay, here we go. Let me see. Real quick. Okay. Okay, I'll be back here. Okay. So let's say you wanted to compare the Earth to Jupiter. Everybody do this. Take your hand, hold it up like that. Imagine that you draw a line around the outside of your fingers and the base of your palm. That's going to be the size of the Earth, okay? Incidentally, you can get all the other planets in there too. Mars is the size of your palm. Clip off your fingernails, and that's Venus. Do this, that's Mercury. Do this, that's Neptune. Do this, that's Uranus. Do this, that's Saturn. And then if you do this, that's Jupiter, okay? You can do this with bananas, whatever you want, just something to make your reach a little bit longer. We'll give this back to you, man. But in other words, Jupiter is a special scientific technical word, humongous. It's gigantic. And I realized that in order for Jupiter to be that small, it had to be really far away. Because like I said, I've flown in airplanes before. You're inside an airplane, it's big enough that it feels like you're inside a house. You can't see the whole airplane at once. You can reach up and touch it and it can fill up your field of view. You can sit inside it for hours and it's like your whole world, right? But it's just a dot, and Jupiter is also just a dot. And I was hit by this sudden sense of depth. All of a sudden, I could visualize for just a second the space between that airplane and Jupiter. And it was this amazing shock. I suddenly got this sense for just a minute of the scale of the solar system, okay? And when I felt that, I said, okay, that felt good. I want to feel that again. So I tried to do things which would encourage that feeling, encourage that sense of depth and space and the gigantic nature of the universe. But there was someone who was already very good at that, that I knew a lot about. And if I say to any of you, older people, shoulder pads and turtleneck, you know what I'm talking about, right? Okay.
Yeah.
Do you know what I'm talking about?
Mhm.
Okay. There's a guy named Carl Sagan.
Mhm.
Carl Sagan was Neil deGrasse Tyson before Neil deGrasse Tyson was Neil deGrasse Tyson, basically. He was an actual astrophysicist. He was a popularizer of science. He appeared on talk shows and things all the time. And, let's see, which laptop using again?
Using the main computer.
Main computer.
I'm gonna do
So
one
right here.
thing and take off some of these.
Just want to make sure we do this.
So our guys can see.
I was trying to go to the next slide here. Just that, or down maybe. Ah, there we go. Okay. Okay. Anybody know the significance of that date? Okay, that was the day that Carl Sagan died. And I remember when that happened, I had graduated by that time. I was working in a photo lab. Remember photo labs? Okay, not like the little photomat booth like in Back to the Future, a place where you actually processed film. You would take film, you would go in the dark with chemicals splashing all over you. You take a roll of film, put it over a machine, hopefully load the machine fast enough. By the time it picked the film up and put it in the tank to process, you'd filled it up and you try to keep up, and it was awful. So I wasn't feeling really great about that job. And when he died, I started thinking about all the things that I had seen that he had done, the show Cosmos and all the appearances on TV. So what I did was I went to the library, and in the library, they had VHS tapes of all the episodes of Cosmos, or at least they're supposed to. The only one that they had was the last one, the one called Who Speaks for Earth. So I said, fine. I took that one out and I watched it, and I hadn't seen it since 1980. So I was like, oh yeah, this is great. But then you get to the very end of the program. And in the very end of the program, what he would do in the show is he would fly around in this imaginary spaceship called the Ship of the Imagination. And what you saw as the last scene in the last episode was the Ship of the Imagination sitting empty with a chair in it. And there was nobody in the chair. And all of a sudden I had another revelation. I was like, he's gone now. That chair is empty. We need people to do what he was doing. So, in some arrogance perhaps, I said, I'm going to be Carl Sagan. So I decided that I would try to go into science education. And one of the things that I did is I volunteered at a park, operating a telescope, just like you do a lot of times. After that, I got a job at NASA. And then I got an internship up in Rochester. And by the way, this internship was in 1997. Actually, it was the year that a Pathfinder landed. So that was 97, right? And even in 1997, the people in Rochester were already talking about this eclipse that's coming up. They were already thinking about it. They said, this is going to be important. There's going to be a total eclipse that's visible from here. We're a museum and science center. We got to start thinking about it. And they have had actually a full-time person coordinating their event for, I think, the past 3 years. So they're really working on it hard. And I'll tell you this too, that if you haven't gotten a hotel room by now, forget it. I actually checked about 2 years ago because I wanted to see if we could get a group of members from the museum to like take a bus up there or something. It was awful. I guarantee you a month before the eclipse, you're gonna find Airbnb rooms for like $950 a night, but don't do that. There's probably easier ways to do it. Go to Spain. There's gonna be a nice one in Spain in a couple of years. Go to Spain and Portugal. Sit on the beach and watch the eclipse, okay? So that was another sort of revelation that I had. And all of these, notice, were driven by this sort of emotional response, right? Not something like, oh, Jupiter's really big and it's cool and something exciting about the mathematics of Jupiter. It was about the visceral sense of the scale of the solar system, the sense of how somebody like Carl Sagan, got me excited. So let's see, what do we do? Whoops, that's not it, right? Sorry, just how do we go to the next slide again?
Right.
Whoops, backwards. Okay, right there, it's fine. Okay. So, yeah, some comparisons. Okay, anybody here, does this sound familiar? Follow the Drinking Gourd? Okay. Okay. Did anybody see a planetarium show called Follow the Drinking Gourd? Up until about 2004, it was really common to see a show at various planetariums that's based on this book. It was actually, the first one was put together by the Newark Museum, and then it sort of spread, and what it really was again, a VHS tape, an audio version of this book with pictures illustrating parts of the story. And then also, as you were reading the book, as you were reading through the book, occasionally they would sing little bits of a song. The basic idea behind this book was that there was a song called Follow the Drinking Gourd. It was taught to people in the South who were enslaved. And in the song, there were secret messages that told people how to evade the slave keepers and the overseers and find help and find their way to freedom in the North. And it had all these things about the right time of year to travel and what animals to listen to, so that you know it's spring. And how do you know you're going in what direction? Well, you would follow the drinking gourd, which is also known as the Big Dipper, right? Okay. A lot of different names, but in this it was the drinking gourd. So I considered, when I started working at the museum, this being a really important thing to do, because, and I've checked on this, I think it's still true. In the United States, there are 4 Black men who are actually in charge of planetariums. I'm one of them. There's no Black women as far as I know. There used to be one Latino woman, she passed away recently. But basically it's me, Neil deGrasse Tyson, Derek Pitts down at the Fells, and up in Boston, there's a guy who actually is the sort of head presenter and technician up there. But that's kind of it. And I was in the Hudson River Museum, which is in Yonkers, which is a mostly Black and Latino city. So I said, okay, here I am, this, whoops. Time for my daughter to take her medicine before she goes to bed. So here I am, this Black man in a city full of little Black kids, how wonderfully inspirational it'll be. I will tell this story and they will learn how their ancestors were tough and clever and they survived. And it wraps into the sky. We'll be able to talk about the drinking gourd and about the North Star and about the weather and about the seasons. And it's the kind of thing that gets an educator excited, because you're able to take a topic that kids may have heard of and you connect it to the thing that you are trying to get them to learn. So you try to connect those two things. However, one time, a group of people came to the museum and I wasn't there because it was on a weekend. Part-time person was there, but apparently there was actually a bit of an altercation. They basically started yelling at the person who was doing the show, saying that the show is inaccurate and that the show didn't reflect reality and it didn't respect the people who actually had to escape and so forth. So the director of the museum at the time asked me to research it. So I spent about 6 months looking into this. I called the Smithsonian Folkways Center, where they are keeping track of things like folk music. I found a historian who has written a great book. If you want to read it, it's called Beyond the River. It's about people who were in Kentucky escaping into Ohio. I tracked her down and I had a phone call with her when she was on her lunch break doing research in a library in Ohio. But because she was in a library and on her lunch break, she had to eat in the foyer because it was too cold outside and she couldn't eat in the library. So she was sitting there munching on a sandwich with one hand, talking to me on the other hand, like that. And after a bunch of research, I came to the conclusion that the story is not true, that this song isn't really true. A lot of the lyrics in the song date from the 20s. There's no record of the song having been sung by anybody before the Civil War. There's things in the song which they say in the audiobook mean this, but actually they don't mean that. So I remember being at my desk and basically putting the phone down with the Smithsonian guy after talking to him a couple of times and looking at all my research. And I remember I just sort of felt this like, oh well, and I just dropped it. And I've always thought that that's one of my proudest moments, because like a scientist, I was presented with new information, and rather than cling to the old thing, even though it was emotionally important, I thought it was really, really important that I do this, that I teach this way as this particular person to those particular kids. I was able to say, no, that's not right, and just drop it. So I was really pleased by that. I thought that was really nice. And there's other things that have felt like that, where I've had to sort of shift priorities. And I think a lot of educators in astronomy are running into this. And one of the main reasons is actually these things right here. It used to be that if you wanted to know about what was going on in the universe, you'd have to go to a planetarium and there would be the expert there with their laser pointer, or before the laser pointer, they actually had like flashlights with a little wire on them. Never mind, kid, it was terrible back then. Yeah. And they'd, sit there and they'd point out stuff and they'd answer the questions and blah, blah, blah with their little tie or their bow tie or whatever. And if you wanted to know like what the latest stuff was from space, You couldn't go online and see it. You couldn't get it on your phone. What you would do is you would write to NASA, and if you were an institution, they would send you things like this. Anybody seen one of these before? This is a complete copy of photographic prints from camera B of the Ranger 7 mission. So what they would do is, as Ranger, which was a probe launched in the 60s, was traveling toward the moon, it was taking photographs. And digital photography at the time was actually a closely guarded military secret. So what they had to do is they had to take the film, process it on board, scan it with a video camera, a very big chunky video camera, beam the information back to Earth analog, and then reconstruct it. And then they would make film, expose that, and then print the pictures. And when they printed the pictures, then you'd end up with this giant thing like this. And I'm just gonna give you a sense of how big and heavy this is. This is nothing but photographic prints, okay? And each one of these represents a frame from one of the cameras on the Ranger mission. So what you would do if you then got this in a planetarium is you'd put this on a copy stand. Remember copy stands? Take a picture of it, make it into a slide, climb up a ladder, put it in the slide projector, project it in the planetarium, say, look, everybody, here's the latest picture from the moon, fresh, hot off the presses, only from 3 weeks ago. Okay. But we don't have to do that anymore. All these images are online. You can go and you can search them and you can find whichever one you want. You can use this and you can point it at the sky and you can figure out what you're looking at. So that whole idea of, information, of knowledge in the sense of how many moons Jupiter has, somebody can look that up. In fact, I always tell kids to look it up because they find a new one once every couple of weeks. So it's like Saturn has what, 138 or something? I don't know. I don't even bother to remember any. They're not even naming them now. They're just giving them these sort of license plate numbers.
Yeah.
So that I've had to change too. And then, because I work in an art museum, you run into stuff like, oops, that's not the right one. You run into stuff like this, okay? Now, I'm gonna ask you what you think you see in this image. What do you see? Anybody here or online?
An eclipse.
An eclipse. No, it is square. It's not an eclipse. I mean, just basically, what do you see?
Black square with a little frame around.
A black square with a frame around, right? If you look at the frame, it looks like maybe it's made out of wood or something, or like little tiles, perhaps. Maybe. What would you say? Looks like wood, maybe. Okay. Here's what this is. This is an image by an artist named Chris Jordan. And what he tries to do is he tries to make art which boils down these numbers which we have floating around our head, like the distance between an airplane and Jupiter, and tries to express it artistically. Remember I said that it was this emotional reaction that really sort of got me, right? So again, I work in an art museum. Really, it's an art museum. At least I'm the only science person there. That's why they always ask me to fix the photocopier. And what happens is that I get exposed to art there, and I get exposed to artists, and I talk to them, and I discovered that, science is cool, but art can actually sort of penetrate past all this thinky stuff and go right to the hindbrain and kind of hit you right there. Let me tell you what this is. This is a work called Year of the Tiger. And the black square with the orange frame around it, the orange frame contains 3,200 little tiny images of little stuffed toy tigers, like little Tigger animals, kind of, right? If you look closely at it, all you see is the texture, but there's 3,200 of them. When he prints these, they're huge. They're like 20 feet on the side, gigantic. But that frame represents all of the tigers that exist in the world today, everywhere. Siberian tigers, Indian tigers, tigers in zoos, tigers in reserves, tigers that people are hiding in their apartments in New York City, tigers everywhere, okay? A black square represents the space that you would have needed to fit all the tigers that existed in the world the year I was born, 1970. So when you see something like that, you might hear, oh, wildlife populations are small, but all of a sudden that really strikes you, right? And it sort of made me think, okay, Jupiter is really cool, but there are lots of people who are studying Jupiter. And remember I mentioned that intern of mine who is a science teacher now? Originally, she wanted to be an astrophysicist. And sure, be an astrophysicist. We need new astrophysicists. But one of the things that astronomy education teaches us is a sense of perspective. That perspective, like the distance between that airplane and Jupiter, the perspective of suddenly standing back and realizing that the truth is more important than being in front of these kids and being some sort of example to them when that example does not reflect reality. Show you something else. This is something that I vaguely remembered. Actually, you can't see the date up at the top there. I think it's 1973 or so. But I remembered this, and I remembered it because my grandfather had a giant collection of National Geographics like upstairs. And I remember reading these. And it shows a jaguar, draped over a tree, obviously the wilds of the forest, right? But I want you to look closely at the actual titles of the articles. In particular, this one down here, keep going to my laptop. Okay, what does that say? Brazil tames her wild frontier, right? So in 1973, the idea was that, well, these huge rainforests we have on Earth, they're great and all, but what we really need to do, we really need to harness them. And I started to think about, like, what would this place be like right now if we had not done what we did? There might still be, chestnut trees around, trees so big that the trunk of the tree would go from here to there and the branches would spread out. They would literally be as wide as this entire room. You could feed an entire family with the chestnuts that fell off the tree. And everybody says that pork used to taste better because you would give them chestnuts. Okay. So as I started to think about this, I said, okay, maybe I can do something similar with some of these other concepts, because I do the planetarium, but I do other education at the museum too. I do things like put leaves in the water and then pull them out and have kids look at the animals that set up shop in them with a magnifying glass. I take kids on nature walks. I go seining in the Hudson. I also talk about the geology of the area. And this is an example of one of these things which I think is so simple and yet so memorable that I would love to emulate this kind of thing. I haven't figured out anything yet that's quite as good as this one, I think. Anybody know what this is? I know I keep asking that.
Plate tectonics.
Plate tectonics. No, there's no question mark shaped countries out there, continents.
Schematic of the museum.
Schematic of the Hudson River Museum. No, Hudson River Museum is on several levels and it's not quite that crazy looking. That's like a hospital that's been around for 100 years. They keep adding new parts to it. I like that. Any other ideas? This actually comes from the same person that did that comic that shows the astronomers getting excited about supernovae or getting terrified of supernovae. Same guy. Guy who does XKCD. What this is a breakdown of the mammals on Earth, on the surface of the Earth. So there's a bunch of different sized blobs. Each one of those represents a different type of animal. Show you, what do you think these different ones are? What do you think this one in the center is right there? These are all different mammals.
York City.
Rats in New York City, you know?
One ran past me the other day.
One building.
Really?
Oh, yeah.
That's humans.
Yeah.
Okay. Each little human represents 1 million pounds of people, right? 1 million pounds of animal. So that's all humans over the middle. What do you think this big one is right there? Good. Beef and dairy cow. Okay. Now, again, this is on the entire planet. Each one of those represents 1 million pounds of cow. Okay. Others, sheep. Gotta have wool sweaters, your mutton. Pigs, chestnuts or no, lots of those. Goats, horses, surprised there's so many horses still, and all domestic mammals. So dogs, cats, oxen, mice, rats, rabbits, ferrets, gerbils, guinea pigs, hedgehogs, whatever. Okay. What's this? Everything else. That's all wild mammals. Okay. And by the way, one of these would be elephants. Now, again, I see something like this and I think, okay, I love to teach people about astronomy. I love to teach kids about the stars. I love to teach kids how to recognize things in the sky. But given this, I can't in good conscience just spend my time teaching kids what the rings of Saturn are made of. Instead, I've started to spend time doing things like saying, you know, all life on Earth uses water. The only thing that we know of that all life needs is water. Oxygen kills some things, but everything needs water. Is there any water anyplace else? Yeah, there's some frozen water here and there, liquid water here and there, but the liquid water on Europa and Mars, it probably has a acidity of like maybe a little bit less than battery acid, and it's all filled with rust, and the soil has bleach in it. Oh, the gravity's low, and oh, there's no magnetic field, there's no radiation, and oh, it would take 3 years to get there, even if you could land where it's safe because there's no radiation, then all of a sudden you have a problem with the radiation to get there and get back again. So I started to think that I needed to use what I can do with astronomy education to teach people, teach kids, give them some perspective, right? Gives them some perspective, not just the size of the universe or the scale of the Earth, but some perspective as to where we fit in things. And all of a sudden, it changes the way you see things. When you start noticing things like this, just like when you start noticing the sky, some of you might remember, I remember when I moved from Rochester to Maryland, I noticed, I'd never noticed it before, that the moon looked different. It was at a different angle. Because all of a sudden I was at a different place on the Earth. I was like, wow, that was kind of a revelation. I started to notice, okay, there's Jupiter. I started to think about the distance between objects. I started to notice that you can actually see planets moving over just the course of a few days or a few weeks. I started to notice that stars are different colors. And as you start to think about what life is like on Earth, then you go to Home Depot and all of a sudden you see this and you're like, wait a minute, is that a good idea? All of a sudden we want to just like destroy things, kills 100 types of lawn damaging insects. Okay, well, maybe because there's something we can do besides the lawn, maybe? Insects were there beforehand. Kills diversity, prevents interesting plants and feeds that, okay? You started noticing things. Again, it sort of changes your perspective. It changes your view. And astronomy gives you a sense of the biggest scale of things. But when you go to the biggest scale of things, the other thing that it does is that it reminds you of how important the small place that we live is and how important the things are that we spend our time learning and doing. And just like I had to just say, okay, I'm not going to do follow the drinking gourd anymore. I said, okay, my astronomy education is now going to emphasize more about things like biodiversity and evolution and sustainability and things of that sort. or poison death. Oh, and this was just funny. Every time I see this on the train, it just bugs me. Is that guy using his lawn? He's in a hammock. He can have like native flowers under there with like bumblebees buzzing. Why does he need a plant? Anyway, that just irritates me. So again, it sort of changes your perspective. You start noticing things that you didn't notice before. So I'm going to close that right there. And last thing I'll say is that I have been working with an astronaut. Anybody know Ron Garan?
Yes,
That's right, he spoke to
yes,
us.
we went to, well,
Yeah, I know he's spoken to you before. He's actually a native of Yonkers. He
Yeah.
has family still here. He comes back every now and then. And he is interested in working with the museum to create something, maybe a planetarium show. And what I want to do is I want to recreate a show which I made several years ago called Ocean of Air, Ocean of Space, which is about the Earth as a planet and the Earth's atmosphere and about the layers of the atmosphere and also about climate change and the greenhouse effect and whatnot. And the reason I want to work with him is because he has said that his perspective has been changed by being in space, something called the overview effect. One picture that I wanted to bring that I didn't have is, you guys know when William Shatner went up in that rocket? Okay.
yeah, his first
So-
perspective, he was crying when we,
Right. So William Shatner was the guy who played Captain Kirk on
Yeah.
original Star Trek, right?
Mm.
He finally got to actually fly in space. Jeff
Yeah.
Bezos put him in his suspiciously shaped rocket, flew him up a couple of dozen kilometers. They drifted around for a while and he came back down. And he was so overcome having seen the Earth from space that he's sitting there trying to explain it. And he's like weeping. And Jeff Bezos is like spraying it with champagne. And you can see the look on his face like, stop it, this is profound. But that's the sort of thing that I want to be able to get people to do, even without flying in a rocket, to get people to connect, to get people to suddenly feel that surge of some sense of perspective and depth and connection. That's what I've been trying to do lately. Okay. So that's what I say when I talk about a sort of changed perspective. What I started out as science education, as astronomy education, and what it's sort of become to me recently. So I think that's actually it. Any questions or anything?
So I have one that actually goes back to the days that you probably remember at the Hayden Planetarium where the shows were live.
Yeah.
And they had the guy had the arrow. It was,
Right.
I forget his name, he had a beautiful voice. And he would interact with the audience and he would drive this ice projector and really was an interactive and heuristic kind of experience.
Right.
A lot of the planetarium shows now, many of the major places are canned. All digital and magnificent graphics and magnificent sound and everything else.
Right.
But you're in the dark, you might as well be in a movie theater.
Right.
And I actually had an interchange 12 years ago. The story is a long story, but I did a review of Dark Universe, which is one of their. And I kind of suggested that you know it's a passive experience and does it really do the things that you want to do, which are really drawing people in. And so the question is the planetarium that you're working in now, the Hudson River, which used to be the same kind of planetarium with his ice projector and a lot. You still do that? And
Yes.
do you amplify that in any way, or do you always have a core?
Okay, so on weekends, there's 3 shows, 3 on Saturday, 3 on Sunday. 2 of them are pre-recorded, 1 of them is live. So every single weekend day, we do a live show. It's an hour long. The people who present it, I don't give them a script. I give them like a page of notes, really more like things to think about as you're talking to people. You know, move around. Don't just stand there talking with the stars sitting still. if you're talking about something in the sky, it should be something they can actually see. If they can't see it, then make that the fact that you're talking about when you talk about it. Say, you can't see it, but beyond here is the giant lighting IKEA cluster, whatever. You know, you could say something like that. So yeah, as a smaller place that's not trying to get millions of people in and out, we can afford to have those 3 shows with like breaks between them. And the breaks between them mean that if somebody is standing around asking some questions, it's not a problem. At a place like the Hayden, to a lesser extent, the Fells, but if it's in a big science center, generally you're trying to get people in and out. So the shows are about 20, 25 minutes long. And even when we do pre-recorded shows, we try to afterwards do a live bit, try to talk about something in the sky, try to mention something that came up in the show. If it's a show about black holes, we'll say, well, at the moment, Cygnus is in the sky, and even though you can't see it in that direction is like the nearest black hole to us, ooh, creepy, creepy, whatever. So they do live shows at the Hayden, I think twice a month. And I was actually approached about doing shows there. And then the person who approached me like left or something. So I'm not sure what the status of that is. But it's more complicated now because like one person can run the planetarium where I work. At the Hayden Planetarium, they have like people running the lights, watching the audience, people running the star projector. Some people can speak and run the computer at the same time, but not everybody can. Like Carter can do that.
Right.
But not everybody can do that.
Yeah, those, we've been to some of those, and we actually had Carter speak to the club. He brought up this guy, it was like 2 hours. We were walking around Mars, you know, it was kind of fantastic. But they're not as interactive with the audience as they were back in the day. I mean, you know, a lot of people remember the first time they saw Saturn. I don't remember that, but what I do remember is that when I was 9 years old, we were in the planetarium and the docent was doing the sky show and he pointed out a star and he said, does anybody know the name of that star? And it was Arcturus, and I got the answer right. And it was like, that was my moment. And I don't know that that kind of experience happens anymore. And I think it should, and you have to try to find ways to, even though it's dark and there's all this technology, to get to those kids.
Well, you've noticed that even as adults, I kept stopping and saying, what's this? What's that? You know, to sort of get people to
Right,
engage.
exactly right. That's
Right.
perfect.
So you do that kind of thing. And, you know, I think that part of that is that, again, because we're not depending on this as the sort of source of information, you simply don't have people asking as many questions because they figure they can look it up later, or they'll like take a picture and I'll just look at the picture later. Because the astronomer is not this authority who's like the only one who knows things, you're not necessarily going to ask them a whole bunch of questions, maybe less than you would otherwise. But so that's why I have, you know, people do funny things with their hands and arms like I just did there before, right? Anything else? Yes.
Hi, I'm Aiden. I'm a college student, and I love astronomy very much, but I'm going to school for engineering because I feel like pursuing that side of science with the application of it. And I'm in mechanical engineering, and I'm trying to pursue an advanced degree in aerospace eventually because I would love to build planes and rockets and all that type of stuff and satellites. And a question I've been asking myself on the topic of preserving the planet while we have it is it best for the planet to build things like rockets that emit tons of carbon dioxide and with the goal of going to a different planet or going to space instead of turning inward and looking at the planet, what we have, on the topic of Jeff Bezos or Elon Musk going to Mars, putting all this money and energy going away from Earth. And when we are, you know, it's dying and species are dying and we can't bring them back. So I was wondering what your opinion on the subject is on going to different planets and the aerospace industry right now.
Okay. I hope that by the time you get into the aerospace industry, there's still space for satellites. It's not all full up with Starlinks.
Yeah.
Because it's getting pretty crowded up there. I would say a couple of things. One is we can walk and chew gum at the same time. We can send stuff out to explore planets. We can send people to the moon. We can even send people to Mars if we want. We are a civilization which has the capability of doing that. And also, genetically engineering American chestnut trees that they're resistant to chestnut blight. Also figuring out ways to, you might have heard there was a dam on the Klamath River that is being torn down and restored so that the salmon in that part of the continent will then have a place to spawn again. And that is the kind of thing that we need to have engineers doing, because if you just blow a hole in a dam, that's a total disaster. You have to understand that hydrodynamics and the physics of what happens to a big structure when it's been sitting for 100 years and so on and so forth. So we do need lots of expertise. And in terms of building things like airplanes and rockets, we're always improving the designs, making them more efficient, making them safer, figuring out how to not have panels blow out of like passenger planes. I thought we would have figured that one out by now. But the reason, one of the things that we've realized about that thing with the panel is that there were already sensors on the plane that were saying that there was something wrong with the seal, but they like neglected it. So is there some other way to do that, to make it more obvious, to emotionally grab the people who are in maintenance and who are in management and say, hey, this is a problem we have to solve? For example, another one thing about that is, so in airplanes now, one of the things that they have is they have these little voices that warn you if you're close to another plane, or if you're in too steep of a dive, or if you're close to stalling. And they experimented with different voices. They said an authoritative, deep male voice saying, pull up, pull up, pull up. A high-pitched, panicked male voice saying, pull up, pull up. So they found that a sort of contralto, calm female voice was the one that cut through all of the noise. Now, maybe that's because most pilots are like middle-aged men or something, I don't know. But that kind of experimentation is the kind of thing that we have to do too. So don't think that if you're interested in spacecraft and rockets, that the only thing you can do with them is send people to fancy jaunts on Mars. As I mentioned, I think that as we start to develop more stuff like that, we will discover that even though we have the technological capability to do it, the problem is the people. Just like a fighter jet can't make a turn tighter than about 9 Gs, because otherwise the pilot blacks out. The jet could do a turn of 25 Gs, fine, it couldn't even notice. But it can't deal with the people. So sending people to another planet where the surface is covered with, like I said, powdered bleach and superfine magnetic dust. Imagine taking this laptop and bringing it to a planet where the entire planet is covered with superfine magnetic dust. What do you think that's going to do to the computer, right? So that's why these rovers cost like $500 million, because it's really hard to make them so they can survive that environment. But we can, as I said, make rovers, send them to Mars. We can send people to Mars too, but there are plenty of other things to do that we need engineers to do. Don't think that that's the only goal. Don't think that you have to aspire to have Jeff Bezos spray you with champagne. Okay? There's lots of other stuff to do. Okay? Yes.
Yeah, the slide showing the relative mass of the cattle and sheep and humans.
Yeah.
Reminds me of the most recent David Attenborough show, Planet Earth 3. They're talking about the destructions of the rainforests and stuff to clear the land. Not some of it is for animals and a lot of it is for crops. But today, more crops go to feeding the cattle and the sheep than for feeding the humans. And, if we didn't need to eat so much meat and stuff like that, we could just have more crops to feed people and, be better for the planet as a whole. We wouldn't have to tear down the rainforests. There'd be plenty of room with the land we already have.
I mean, I think that we don't necessarily need to not have hamburgers anymore. It's not like we're going to let dairy cattle go extinct. Try to let dairy cattle go extinct and have the French be okay with that. They would lose their cheese. They would not like that. Right? But what we can do is we can continue to do those things, but with an adjustment in policy and where our money is going and how the market works. Actually, kind of small adjustments here and there can change things a lot. the political change in Brazil recently, when Lula da Silva came in and Bolsonaro was out, the rate of deforestation in the Amazon dropped because Bolsonaro had it as his specific goal to tame her wild frontier, right? And Brazil seems to still be pretty prosperous. They're doing okay, as last I checked. So it doesn't need to be that we do things the way that we've been doing them, and that's the way that we succeed, and we can't do things another way. And it doesn't need to be that you swing things around 180 degrees. A few small things here and there can actually make a big difference. And yeah, don't think that don't think that you need to just like jam on the brakes and stop everything right now. We know that one of the things that astronomy teaches us is that the Earth is very resilient. It's gotten hit by asteroids before and life has survived. So Earth itself is going to be fine. Life itself on Earth is going to be fine for billions of years more probably. But what we have to worry about is the fact that we've set up a system where, for example, we're getting lots of grain from Ukraine. What happens if that is disrupted, right? That's the kind of thing that's more of a concern. Okay, yeah, you had a question.
I wondered about misinformation and if you get challenged with shows, with programs, with things you do. I was up in Boston a few years ago at a medical conference and I went to the Science Center and I was just walking around. It was great. And there was a fellow there doing a program. I'm trying to think, it may have been on electricity or magnetism or something. And he was doing great, and this flat earther was there and he challenged him, and it was almost comical, really, because the speaker had him over the barrel, but this guy would not give up on the flat earth society, and he had all these things that he was trying to explain to the audience, and people were just getting up and leaving, but there's a lot of that now, and I wonder, every once in a while my husband and I will do programs with Girl Scouts as an outreach for our club, or sometimes just through different things. And I've got little kids that are starting to repeat things that they've heard, probably at home. And it's not accurate, and it's not even truthful. It's not even real. And I worry about evidence-based science. And I just wonder if you've had experience with people just saying crazy stuff, either because they believe it or they want to make themselves appear different and a little more intelligent than everybody else, or why people just repeat stuff that I think basically they know is not true, but in science.
Yeah, so every now and then there is a phenomenon in museums called the dad knows phenomenon.
Oh, sure.
So you go into a museum and somebody sees the Apollo capsule there, and the little kid asks, "Daddy, what's the heat shield made out of?" And they say, "It's made out of steel." Yeah, it's made out of steel. And it's like, it's not. And it's actually a really interesting story what it is made out of and how it works and so forth, but you just sort of say steel, right? I have had a few experiences, not so many at the Hudson River Museum. There's been a couple. I had a bunch up in Rochester, people coming and insisting that there had been a giant flood that covered the whole world. And then when I went to them and I said, well, actually, there's no evidence of that. They just looked at me blankly, like they've always been taught that it was. And I think that if you are trying to reach kids and you're concerned about them picking up misinformation, one of the things that you can do, remember that we didn't always know the stuff that we did, right? We didn't always know that the soil is full of microorganisms and that most of them can't harm us, some of them do, and we didn't always know that the earth is a big ball floating around another big ball and so on and so forth. So what you do is you expose them to these sort of basic concepts, you give them experiences, and they start asking the same questions that our ancestors asked. And you make sure that you get that foundation down. And they will still hear stuff that's contrary to that. But if they know that they have been asking questions themselves and they've gotten really interesting answers by examining it themselves, then I think that that helps them understand things. I call someone who has been taught, something contrary like that for a long time. I say that they've been armored against understanding, basically. There was one time these three girls came to the Davis Planetarium in Baltimore, and afterwards they were trying to explain to me how it didn't mesh with, what they'd been taught in their church, I guess, about what actually happened to the dinosaurs. And one of them said, well, because if an asteroid hit, it would just like destroy South America. But in the show, they specifically say the asteroid hit and it caused all this other effects that circled the whole planet. But it was like there was a filter that had prevented that from reaching her. And I consider myself fortunate that I haven't run into that too much. Usually it's something more along the lines of somebody has some sort of misconception and they're kind of open to the idea. But yeah, sometimes you get people who are obstinate. One time this older couple came up, and this guy who, clearly was enamored of these little devices, he said, how can we say that technology won't solve this problem? I mean, technology made this. How can you say it won't solve the problem? And I tried to counter that in one way, but there's actually two things I wish I'd said. One is it has already solved the problem. This allows us to make, in a compact space and in a finite amount of time, make a simulation of the Earth's entire environment. And we can then adjust it slightly and see how things turn out. So we know what the problem is. We know what we have to do to solve it. It's already been solved. The other thing is that if he's saying technology will solve the problem, I would then ask him, do you know how to use that technology to solve that problem? So, oh no, of course not. So who's gonna do it? And I said, well, some young person. Okay, so you're saying to that young person over there, I know that you really want to be, I don't know, a hairdresser. You really want to design shoes one day. You want to be a race car driver. Sorry, you're going to have to solve this problem because I'm just going to leave it up to you. Okay.
Yeah.
So those two things too, I think, important. But yeah, that is a problem, and we are discovering how big a problem it is. And like a lot of people, I'm concerned about it. I don't know exactly what the solution is. There probably is no single solution. Probably needs to be a bunch of different things. Need education. We need, to have sort of rival, diverse systems where people are learning things. Lots and lots of newspapers, lots and lots of TV stations, lots and lots of streamers. There are some people who do YouTube channels who are great. Anybody know Answers with Joe? No? He's a great guy. He's one of my favorites. He tackles really, really cool topics. He does a fantastic job of it. You might have heard of Veritasium, that's a few of those. So they actually have these really excellent YouTube channels. It's not just influencers peddling,
Dr. Becky, have you seen Dr. Becky?
Yes,
Yeah,
yes.
she's fabulous.
Yeah, there are some out there, right? And not necessarily professional astronomers like her, just people who really know how to do actual research. You ever seen that meme? Sorry, I gotta mention a meme. It shows a woman with splash goggles on in a lab coat with all this equipment behind her, and she's like titrating some stuff. And underneath it, it says vaccine research. Then underneath it, there's a very similar looking woman sitting on the toilet with her phone. It says anti-vax research.
Any other questions? Anything from,
Oh, Daryl.
Let's get one.
Daryl.
Al?
What, was there someone else?
No, no.
Good spot.
Oh,
Go.
Yeah, I hate to have the least profound question of the night, but
Okay,
I love that, what I assume is a lunar phase prompt.
it
So-
is a moon phase teaching device, which I can demonstrate.
Okay,
once-
yeah, I wonder if you could demonstrate it, maybe if you could just briefly put it in front of the camera for all our remote. Okay.
Yeah.
What's your name? What's your name?
Liam.
Liam? Why don't you come out here? Okay, So I've tried a lot of different ways to teach the phases of the moon. You've probably seen the diagram of the Earth and the moons and all that stuff. And I hate that because it just never works. You can't visualize that. So instead, we made this. And I don't know who invented this. I did not invent this. This is like the third version of it. We have the fourth version at the museum. But I will ask you, Liam, what do you think those are? They're the moon, okay. Are there really 8 moons around the Earth? No, there's just one, right? So each one of these is like a couple of days apart, right? So the moon, okay, so the moon is moving around the Earth. Now, if you look at these moons, do they look kind of the same or do they look different? They look a little different, but are they all black on one side and all light on the other side? Yeah, okay. So this right here shows you where the sun is. So the sun is over there. So it's shining on this part of the moon, lighting it up. So that's the what side? What do you call that when you have a planet and the sunlight is shining on it, the part that's all lit up? It's a complicated scientific word. It starts with a D, 3 letters. Anybody?
Daytime?
Day, right? Daytime, right? Day, which means this side is nighttime, okay?
you say, John?
So they all are facing the same way, right? And they all look kind of the same in terms of light and dark. But on the Earth, are we out here looking at the moon? Where are we?
Yeah.
Well, we're here, but if you had the moon and if you had a model of Earth and Moon system, where would you put a Earth in this? Where would it be? It'd be in the middle, right? So we're looking at it from the middle, not from out here. So when you're in the middle, now look around. What do you see? The moons look the same?
Yeah.
No. Where's the full moon? All lit up. Yeah, right. Where's the new moon where you can't see it at all? It's just the nighttime side. Yeah. Which one is a half of a circle, quarter moon? That one. Is that the only one? Look around. Yeah, that one's if you try to teach that with a sheet of paper with a bunch of little circles on it, it doesn't work. But now you understand that. You're ahead of 90% of the people in the world probably now. A lot of people don't get how that works. Say it's the shadow of the Earth. Okay, thank you. You can sit down. So, you're sort of using the fact that your brain to a lot of people has a hard time manipulating the stuff. And those charts were usually made by people who were really, really good at manipulating stuff. Mechanical engineers, you can take parts and rotate them in their minds. You pesky people who were good at 3D manipulation, right? But if you're not so good at that instinctively, the only way to do it is to, rather than have people rotate things in their minds, actually put them in the position so that you simulate how things work. And just like you saw him, he's like, oh yeah, there's the full moon, there's the full moon. I think you just understand how it works.
Thank you. And
Sure.
we have the club. Thank you so much. Science, fighting ignorance and superstition.
I'm trying.
Superstition. That's great.
If you want to come up and look at the ranger images, we'll do that.
Okay, we're gonna sign off and hope everybody has a good month and we'll see you in February.
Yeah.
Thank you.
If you have.